Hi everyone, in this video we will study red-black trees. Now red-black trees is a special kind of tree which is always balanced. Now when we studied binary search trees, you would have realized that a binary search tree is not balanced. It could be very lopsided. Now a red-black tree is a kind of tree which is always balanced. To have that, what we have is this data structure requires one extra bit to store color at every node. So at every node you have to store the color. Now it has four important properties. The first property is that every node is either red or black. Now the root and the leaves, here the leaves are the nil or the grounded nodes, they are all black in color. Now if a node is red, then its parent is black. Okay? So this is a very important property. The fourth property is the most important, and let's try to understand this. Now all simple paths from a node X to the decadent leaf have the same number of black nodes, and this is what we call as a black height. Now let's try to understand each of these properties with an example. Now this is an example of a red-black tree whose height is 4. Okay? So the height of this red-black tree is 4. Now let's study the first property. The first property says that every node is either red or black, and this is satisfied in this example. You can see that every node has a color which is either red or black. Let's look at the second property. The second property says that the root and the leaves are all black. Now note that here by leaves we mean these nil nodes or the grounded nodes, and they are all black in color. The root is also black in color. So the second property is also satisfied in this example. Let's look at the third property. The third property says that if a node is red, then its parent is black. So for example, let's consider this node 8 and this node 11. We can see that its parent, which is 10, it is black in color. And that also holds true for 18 and 26. So this third property, that if a node is red, its parent is black, holds true for this tree. Now let's study the fourth example, or the fourth property, which is the most important. All simple paths from a node X to the decadent leaf have the same number of black nodes, which is called the black height. Okay, so let's first look at this node 18. Okay, now how many paths does it have from itself to the decadent leaf? Actually, it has a bunch of paths. Let's just study them. There is one path like this. There is another path going to this leaf. There is one path which goes to this leaf. There is another path which goes to this leaf. There is one that goes here. There's another one which goes like this. And there's a third one here which goes to this 26, and this goes to this leaf. So there we can see that there are 11 paths, 11 simple paths from 18 to the leaf nodes. Now, what the fourth property says is that all simple paths have the same number of black nodes. That is an important property that has to be satisfied. So if we look at this example, we'll see that from 18, all paths have exactly 2 black nodes. So if you consider this particular path here, just highlighting it again, there is one black node right here, and the next black node is actually this 10 here. So it has 2 black paths from the leaf node to 18, and that holds true for every simple path from 18 down to the leaf. Now, let me just erase all this to make it a little easier to look at. Now, this property holds for every node in this tree. Now, if we want to consider this node 22, we will look at it and will understand that it has one black node to its decadent leaves. So it has three paths. This is one path, this is the second path, and this is the third path. All these paths have one black node, and the black height is going to be 1 for this. Let's consider the example of 10. It has 4 paths, and the number of black nodes on this path are just, in each path is just the nil node, and therefore the black height of 10 is 1. So with this, we'll conclude this first introductory video on red-black trees, where we studied the 4 different properties of red-black trees. In the next video, we'll study how to insert a node into a red-black